All right, here we are in chapter 15, the last chapter of C101, and we are on the last video, or the video 4. So in this one, we are now going to look at our relationship between concentrations of hydronium and hydroxide and how that relates to pH. Why do we use the pH scale? Is that something you're used to and familiar with? It probably is. If you've ever had to go and test a swimming pool, all right, you probably have used pH paper to kind of see where it is. If you have a fish tank, you might also try to use it to get your fish tank to the right pH, and that's very critical to keep fish alive. I have killed quite a few fish in my past. Even though I'm a chemist, it still is hard. It's a tricky thing to get that water right. But anyways, pH is harder, or is easier to understand, okay? It's a little bit easier to sometimes test, and the concepts to understand what is an acid, what is a base based on pH, compared to talk about hydronium and hydroxide concentrations. So we're gonna find how we go between one and the other here. But before we do that, we need to just talk about logarithmic scale in general. So pH is the logarithmic scale. Okay, other things that are in the logarithmic scale is the Richter scale for earthquakes. So if you hear about, oh, the earthquake is on the scale of 7 versus an 8, what does that mean? Okay, so let's look at what that means a little bit more detail. Just quick little information here. A logarithm is an exponent. Okay, so it's basically the power to which the base number, and since this is log base 10, our base number is 10, is raised. All right, so here's kind of an outlook. So the log of a number is x. That's saying that 10 raised to what, okay, is that number. Let me put that in another way. We will say the log of x is the power to which 10 must be raised to obtain the value x. All right, so let's do an example. If the log of a number is 2, what is the number? So we're saying that 2 is the x. That's the log of a number. What would be the number? That would be this part right here. So log of something, and that something is 10 to here, is 2. That means that 2 is x, so 100, 10 squared, sorry, not 100 squared, 10 squared, or just 100. All right, so if the log of a number is 2, the number is 10 squared, which is 100. All right, so what is the log of 1,000? Well, we can write log of 1,000, which is equal to log, and we can break this into an exponent of 10. The log of 1,000 is the same as log of 10 to the third, right? 1,000 is 10 raised to the third. Well, the log of 1,000 then is what 10 is raised to get to that number, so this is 3. So the log of 1,000 is 3. All right, so we will be using this with pH. You actually will be taking the negative log, so you just have to put a negative number in there. And we'll get into that into the next slide, but let's just look at, sometimes you have to also be able to go from the log back to the number. So you have to go between the log of the number and the number. Get your calculator out, okay? So everyone make sure you can do these on your calculator. They're not always gonna be all nice factors of 10, so you have to kind of figure these out. So on your calculator, you should see the log button. All right, any scientific calculator will have a log button. And then oftentimes you have to hit a second key, and then you have other options then that occur. So on top of the log button, usually we call it the anti-log or the inverse log, and you will see 10 raised to the x, okay? So that's what we call the anti-log. That's to go the opposite way. So if you are asked, first off, what is the log of 250? On my calculator, I would type in and press the button for log, and then I would hit 250, and then I'd hit enter. And it will read out a number. And the number it reads out, if I write down a couple sig figs, is 2.398. You should make sure you can do this on your calculator as well. The reason why I kind of emphasize that you should try it on your calculator, the one that you will use for quizzes and exams, is that some calculators are different I've seen some calculators where you type in 250 and then you hit the log button. So it just kind of is based on what calculator you have, know how to use your calculator. So the log of 250 is 2.398. All right, this is basically saying what 10 has to be raised to get to 250. So we can then go the other way, okay? If the log is 2.398, what is the number? Okay, well, what is that asking again? If the log is this, what is this number right here, okay? And so we need to take 10 raised to the 2.398. Okay, so instead of typing in log of 250, I want you to type in 10 raised to the 2.398 on your calculator. So for me, I have to hit the second button first. It's yellow on my calculator. Then I press log, and it will show up as 10 raised to, and then I type in 2.398. I hit enter, and I get back to 250. All right, so this would be called taking the log of a number, and this we'd say is called the anti-log or inverse log when you take 10 raised to the log to get back to the number. Whew. All right, mouthful there. Let's then go and look at what this means with the pH. So next slide. pH is a way that we'll talk about if something's acidic or basic. You have heard of this scale before. It is logarithmic, so we'll be using the log. A couple things that you probably know already, but the pH scale we'll say usually goes from 0 to 14. And in that range, you have an acidic area and a basic area, and then right in the middle is neutral. So here you can see the pHs listed. And the low pHs, those would be the numbers below 7, is in the acidic range. And the numbers above 7 are your basic range. So the lower in pH you are, the more acidic the solution is. The higher in pH, the more basic. All right, and so you can adjust the pH as a solution. So if you are dealing with a swimming pool and it's too basic, you would add some acid. If it's too acidic, when you measure the pH, you would add some base to it to try to neutralize your solution. Acids, bases, very important. There's a little section in the end of this book about buffers and how those are important. I won't get into that too much here, but very important to understand how pH works. All right, so relationship here between pH, acidic, and basic, and then we'll talk about how you solve for pH. So if your pH is less than 7, we said this is acidic. If your pH is equal to 7, it's neutral. And if it's greater than 7, basic solution. All right, how do you go between hydronium hydroxide and pH? That's the important thing. Our definition of pH is that it is the negative log of the hydrogen ion. But we know hydrogen ions in solution make hydronium, so I'm going to say it's the negative log of the hydronium ion. So to find the pH of a solution, you need to know the hydronium ion concentration. If you know the hydronium ion concentration, it's really easy. You just type in negative log and then the hydronium ion concentration, and you'll be spit out with the pH, which should usually be between 0 and 14. If that pH is less than 7, it's acidic. Greater than 7, it's a basic solution. All right, make sure we can do an example here. If your hydronium ion concentration is 1 times 10 to the negative 3, then pH is the negative log of 1 times 10 to the negative 3, which ends up being the negative 3, which is 3. Okay, you can see that negative sign comes right there, and this comes from right here. So you just end up with a positive value. Calculators can also vary with this as well. When you have to do the negative sign, I type in negative log, and then I put in the concentration on my calculator, but I've seen other students who have to type in their concentration first, then log, and then multiply it by -1. So figure out your calculator and know how it works. All right, there is a relationship between how all this works, okay, and you should be able to recognize whenever you multiply the hydronium times hydroxide together, you get the kW, or 1 times 10 to the negative 14. So anytime, it doesn't matter where you are on the pH scale, if you take the hydronium and hydroxide ion concentration, you'll get that equilibrium constant. So here was at neutral, 1 times 10 to the negative 7 times 1 times 10 to the negative 7, you got 1 times 10 to the negative 14. If you're more basic, that means you have more hydroxide than hydronium. All right, that's the case here. If you take 10 to the negative 4 for hydroxide times 10 to the negative 10 for hydronium, you also get 1 times 10 to the negative 14. All right, so it doesn't matter where you are. And you can see how the hydronium ion concentration relates to the pH, and it's easy to see when you have it in a factor of 10. So 1 times 10 to the negative 8 ends up being a pH of 8. All right, times 10 to the negative 12 for hydronium, you have a pH of 12. All right, I think we can now look a little bit more about what this really means for the logarithmic scale for pH. So putting this together, I have some common substances here listed on where they are on this pH scale. And key thing, okay, the concentration of hydronium and hydroxide can be very spread out, and then pH is not as much. And that's because each change in pH, okay, so a decrease in pH, if the pH is going down, that means you're becoming more acidic. So a decrease in 1 pH unit represents a 10-fold in the concentration of the hydronium ion. All right, so let's try to make sure we got a good grasp of that. Which solution is less acidic, lemon juice or tomato juice? So that's the first question. Which one's more or less acidic? When I read the word less acidic and I see it's bolded there, okay, what does that mean? Are we looking for less acidic? That means it's more basic. And to be more basic, we would be looking for something with a higher pH. So when I'm looking at lemon juice and tomato juice, the way I'm comparing them to see which one's less acidic is the one that has the higher pH. Lemon juice is over here at pH of 2, tomato juice roughly right around 4. So tomato juice is less acidic because it has a higher pH. Now, it has a change by 2 pH units. Now, each pH unit stands for a 10-fold decrease in acidity. All right, so if it's 2 pH units, that's 10 squared, that's 100 times less acidic. All right, so that should be able to tell you that even small changes in pH stand for very large changes in the concentration. All right, can we do some practice problems? Let's get calculators out and let's try to work through a couple of these together. There are now a couple key equations. You have the equation for figuring out hydronium and hydroxide ion concentration. All right, so let's just write our equations down. OH minus times H3O plus equals the KW, 1 times 10 to the negative 14. You'll use this equation when you know one of the concentrations and you're solving for the other. All right, and the other equation is the pH, and we have that as the negative log of the H3O plus. You'll solve for that one when you know hydronium, but you don't know pH, and so you're going to plug in the hydronium ion concentration and solve for pH. Now, if you know pH and you're trying to go to hydronium, you say that hydronium concentration is 10 to the negative pH. All right, those are the 3 equations, and we can do all these problems based on this. Hardest thing is probably identifying where you're going and which equation to use first. All right, so first one, if you have a hydronium ion concentration of 1.4 times 10 to the negative 4 molar, okay, what is the hydroxide ion concentration? We're going to use the first equation that relates hydronium and hydroxide. Hydroxide is the KW divided by hydronium. All right, without even looking at this, I can tell you if it's acidic or basic, right? And you can too. I'm comparing the concentration for hydronium, 1.4 times 10 to the negative fourth, to what the concentration would be if it was neutral, 1 times 10 to the negative 7. This is greater than that, so I can tell right away that this is acidic. It's always good to do these checks in your head as well. All right, we can solve for this, and I get 7.14 times 10 to the negative 11 molar OH minus. And again, we can see acidic because hydronium is greater than hydroxide. And then it's even easier to see if it's acidic or basic just when you find the pH. So the pH is the negative log of hydronium. And when I solve this, I get 3.85. Since this pH is less than 7, another way to say it's acidic. All right, the second one. This time, I don't give you the concentration of hydroxide or hydronium. I'm giving you the concentration of HNO3. You should be able to recognize HNO3 as an acid. Okay, it has a proton to get rid of. And you should know its name is nitric acid. And so before I can find the pH of this, I have to find the concentration of the hydronium ion in nitric acid. Now, one thing you should recognize is that this is a strong acid. So it completely dissociates. And just by that, you should be able to look and say, hey, this HNO3 only has one hydrogen. So when it completely dissociates, it will dissociate into H plus and NO3 minus. So the concentration of a strong monoprotic acid, go like that, equals the concentration of hydronium ions. And that's one way that you can now switch it over. So we can say, hey, this is a strong acid. It completely dissociates. It breaks down to one proton. So the concentration of the acid is also equal to the concentration of hydronium ions, which then would lead us to write hydronium ion concentration 3.0 times 10 to the negative 2 molar. All right, now that we have that, we can go and solve for hydroxide. And hydroxide would be 1 times 10 to the negative 14 over the hydronium 3.0 times 10 to the negative 2. Solve for that. I got 3.33 times 10 to the negative 13. And when I find the pH of this, the negative log of 3.0 times 10 to the negative 2. On my calculator, I got 1.52. This is less than 7. I will say acidic. All right, there's one more left. I think you have all the tools you need. Take a second, pause the video, come back in a couple seconds with your answer, and I'll go through mine as well. All right, welcome back. I hope you took that time to now work through this problem on your own. Hydroxide ion concentration was given at 8.5 times 10 to the negative 5th. You have to solve for hydronium before you can find pH, okay? Some students might be tempted to stick in the OH minus concentration instead of the hydronium in the pH equation. You don't want to do that. You actually are finding the POH. You can do that, but that's not what we're asking for. We want to find pH. So get hydronium ion concentration, take Kw divided by OH minus. I got 1.18 times 10 to the negative 10 molar. Right there, comparing the hydroxide and hydronium, I can see I have a lot more hydroxide. I know I'm going to be a basic solution, but I still want to find the pH. Take the negative log of the hydronium, and I got a pH of 9.93. All right, we should be pretty good with these, but just to verify, let's make sure. Can you find the pH of a solution that has a concentration of hydronium of 3.15 times 10 to the negative 8? So pause the video again, do this last problem, we'll come back for it. All right, welcome back. I hope you were able to plug this in and solve for pH. It was 3.15 times 10 to the negative 8 molar hydronium, really close to what neutral is at 1 times 10 to the negative 7. So we expected it to be close to neutral. 7.502 is what I got for the pH of this solution. You have now gone through this whole chapter, okay, and let's look at all of the stuff we have completed here. Whew, there we go. Learning outcomes. So we have looked at electrolytes, dissociation, what it means to be an electrolyte, strong, weak electrolytes, being able to identify those, looking at a lot of stuff with acids and bases, their neutralization reactions, also looking at the other definition with Bronsted-Lowry, conjugate acid-base pairs, being able to identify those. And then we looked at water as both an acid and a base. Okay, so lots of stuff here, and then using that and the equations we get from that, we were able to go between concentration of hydronium, hydroxide, and also pH. We can add this into some stoichiometry, and we can do lots more problems. I hope you work on a bunch of them as you finish up your learning of Chapter 15.